This video is going to cover the problem that is labeled 2002 B2. So first of all, as you read through here, the important thing to notice is the particular object has a total energy of 0.4 joules. However, they drew a diagram that goes on beyond 0.4 joules. I don't know why they did that. The only reason I can think of is to confuse us. But really, I drew this red line here saying that is the end. It's not going to go any higher than that. Notice that the y-axis is U in joules. That is potential energy measured in joules. So let's just keep that in mind. Our x-axis is our x measured in centimeters. Okay, so the object's potential energy when its displacement is +4 from the equilibrium position. Here is +4. It is right about there. That is at about 0.05 joules. That was just reading the graph. Part B. What is the farthest the object moves along the x-axis in the positive direction? Okay, it starts here at 0. That's an equilibrium point. And it goes all the way. Remember that it stops at 0.4 joules. And so that stop happens at 10 centimeters. And it says explain your reasoning. You should write something about that if Emax is 0.4 joules, that is where it hits the 0.4 joules. Take a minute to explain that. I'm going to let you write that out. I think I did include that in the answer key that is printed. Part C, determine the object's kinetic energy when its displacement is -7. All right, they are being pretty nitpicky here, but then when you read graphs, they want you to be reading very precisely. So you might have thought that was at 0.2. I actually thought it was at 0.2 also, but as I look closer, maybe it's closer to 0.18. And so the potential energy is 0.18, but our total energy is 0.4. So that must mean that what's left over is the kinetic energy, which is 0.22 joules. Because the kinetic plus the potential has to equal the total, and the total is 4. Last question, what is the speed at x equals 0? Well, to find speed, we're going to use 1/2 mv squared. And our total energy is 0.4 joules. So those two things have to be equal to each other. So we also know they give us in the problem that the mass is 3 kilograms. And now it's just a matter of using our calculator and coming up with our answer. So doing some math here, we might get 0.1 over 1.5. Take the square root of that. So after you do your calculations, you come up with 0.52 meters per second.